Hi, welcome to the third and final part in this video tutorial series. In this video, we'll be showing you how to make this professionally finished pre-preg carbon fibre airbox using the complex 3-piece split mould that we made in the previous video. If you're new to pre-preg, check out our complete introduction to pre-preg carbon fibre video. In that video, you'll find lots of information on the handling, processing and curing of this material. For what we're doing today, we can keep things really simple because almost everything that we're using to produce this part comes in our Pre-preg carbon fibre starter kit. In the kit, you've got all of the consumables that you need. You have 5 metres of vacuum bagging film, unperforated release film and breather cloth. You also get a high temperature silicone vacuum hose, through bag connector, 2 rolls of vacuum bagging gum tape, and optionally, if you don't already have a pump, a Composites vacuum pump. Then, of course, the Pre-preg itself. We have over 1.2 square metres of both the Easy-preg surfacing layer and the Vari-preg backing layer. This is dispatched straight from our freezers in sealed packets and stored on a roll. One of the great things about working with pre-pregs is how accurately and efficiently you can cut the material. So the first thing we're going to do here is just lay masking tape onto these moulds to give us some accurate cutting templates. This one's a very simple part to template for because we're going to laminate this in one component. When it comes to the lower section, we actually want to laminate these two while they're fastened together. So I'm going to bolt these together now and then create the masking tape template inside there.
When deciding where to put cuts in the material, you should consider both the cosmetic appearance of where the join will be and also the ease with which the part can be laminated. In many cases, this will mean locating the join in a corner on the mould. Corners visually hide the join and also make it easier to lay up without bridging.
You can transfer these templates that you've made onto any material that you like. We're going to be using fluted signboard as it's very easy to cut and fairly durable.
With templates from compound shapes, you will find that they often will not easily lay flat. In these cases, you should flatten them and interpret the true shape as best as you can.
With the rough templates down, we've got to consider before we cut these out whether any of them need extending or how they're going to sit into the mould. This will be our first component into the mould, so we want this piece of material to be precisely cut to that line. So this won't get changed, it will be cut out at that size. However, where the join is, it's much better to have an overlap of material rather than a butt join. So we will extend the side panels here out by around about 10mm to give us that overlap. When we're looking at the top section, we'll be cutting this one slightly oversized just to give us an extra bit of tolerance, some margin for error when we're laying it up before precisely cutting it down to the seam on the mould. So these are the basic templates now, and you can see roughly how they'll sit into the mould itself. Now the other thing that we want to consider is wherever these parts are joining, so where that part meets that part, we'd like the weave to align. So there's a simple trick to doing that, and that is to mark up the orientation of the weave on the respective components. So again, with the top section there, which will be in that position, we can do the same thing and ensure that the weave along that join will line up. Before we go on to cutting out the pre-preg material itself, we're going to take the opportunity to apply release agent to the mould. Now, as you may have already gathered, we've produced a part from this, so it's already had several applications of release agent, but it's always a good idea between every release to apply one more application. Normal release agents, conventional release agents such as wax and PVA, they don't work for pre-pregs because of the high temperatures that are involved, so you really have to use a chemical release agent such as Easy Release. Now, when this part is actually vacuum bagged, some of the resin will get driven between the parting lines. So it's equally important to get release agent onto the flanges of the mould as it is onto the main surface of the moulding. So we'll be applying the release agent right over the surface, over here, and also these areas here and here. If you've been storing your pre-preg in a freezer, make sure it's fully defrosted before you unpackage it. We need a piece of the surfacing and a piece of the backing ply of the pre-preg. The special Prepreg surfacing ply you can identify by the fact it's dry on one side. This Prepreg really is the secret behind getting a pinhole-free surface finish. The backing ply is much heavier material, made from a 430 gram cloth, and that can be identified by the fact it's got a plastic covering on both sides. You're looking to get these templates nested as tightly as you can, thus avoiding waste material. Cutting the Prepreg is very straightforward as long as you've got a substantial pair of shears. The surfacing layer, being much thinner than the backing, can be cut quite easily with either a pair of shears or a knife. Now we can see here how we're looking to get the weave alignment. This is the first layer into the mould, so this is the piece of material that you see. So we're looking to ensure that our weave alignment is absolutely perfect on all of these parts. With the twill fabric, you get quite a distinct line running in the diagonal across at 45 degrees to the weave. And these lines here, we're looking to align those with the lines that we can see on the surface of the material. So we'll just be taking the templates and making sure at every stage that that line carries through from the ones that we've marked. The excess material that we've got here, if it's not going to be used immediately, that can be rolled back up, put into a sealed bag and refrozen. With our kit of Prepreg ready and our moulds prepared, we're now ready to start the layup.
First, loosely place the material into the mould, ensuring that it is accurately in position before firmly pressing against the surface. It is good practice to work the material from the centre outwards. This ensures that the material is in intimate contact with the entire mould surface. Any air pockets or bridging of the fabric in corners must be driven out. In a cooler working environment or for intricate shapes, it's sometimes advantageous to slightly warm the Prepreg using a hairdryer or a heat gun to make it tackier and more pliable. In the case of this part, however, it won't be needed. The backing ply is laminated in much the same way as the surface, but extra care must be taken when placing it into the mould, as repositioning can often disturb and lift the surface ply beneath. You will also find that this heavyweight material is less pliable and can take a little more force to manipulate. Prepreg laminating tools are often used to aid the laminating process. These normally consist of a range of blunt implements, often hand-shaped by the laminator from plastic or even carbon fibre. These are then used to push, manipulate and burnish the material firmly against the mould surface. If ever there is a fault in a final component, 9 times out of 10 it would be small pinholes in a corner. This is as a result of material bridging. You must pay extra attention to corners, ensuring that there are no voids between the mould surface and the Prepreg. With the 2 plies properly laminated into the mould, the excess is trimmed off with a sharp knife blade. Ensure that the blade is kept flat and does not scratch and damage the mould flange. You should make sure that the cut line is neat and level with the flange. This will ensure a neat join in the part is provided. With the upper section complete, we will now move on to the slightly more complex layup of the lower mould tool. Starting with the base piece of material, this is laid precisely into the mould. The edges of this piece will be the visible join on the part, so accurate placement ensures a neat final finish. To make handling easier, the hole for the aperture is not cut until the piece is in place. The hole is then simply cut with a knife. The side pieces are then placed into the mould. If you remember, these are cut slightly larger to allow for overlap onto the first piece. In the case of this part, the overlap of around about 10mm will provide a strong joint. When curing, the resin will flow around this joint, making a seamless finish at the point of overlap. To make the layup easier in the corners, I'm snipping small nicks into the material. I'm only doing this where the material is overlapping, so that it won't excessively weaken the part or be visible on the surface. Again, here I'm using the same Pre-preg laminating tool mentioned earlier to ensure that this special surfacing Pre-preg is pressed down firmly against the mould surface. Small snips are used again in the corners to allow the material to be folded into the mould with minimal distortion. A real benefit of working with Pre-pregs is the way that intricate layups, like this, can be carefully assembled step by step, with the Pre-preg tacking itself into place on the mould surface and staying in position. Again, the backing layer we're laying down here is tacky enough to stick nicely to the surface layer. We position it carefully and then apply pressure to stick it down firmly. Excess reinforcement is easy to trim away using scissors or a knife.
That's the pre-preg carbon laid into both of these two parts. You can see on this one, we've cut the carbon completely level with the flange there, whereas on the other half, we've left around about 15mm on the top. That 15mm flap will be folded in, but then we'll join the two together when we come to the vacuum bagging stage. I'm going to put a few small snips into the carbon around the corner here to allow the flaps to be folded in without creasing.
We'll fold these over and give them a quick press so that they're lying into the mould, and then quickly get the lid section on before they get a chance to straighten up.
Now we've got these two mould parts bolted together, you can see the extension that we left on the lower part of the section will overlap over the upper part, making a very strong bond between the two. With the layup complete, we're now going to move on to the vacuum bagging. It uses a completely conventional vacuum bagging stack, so we're using the materials that come in the kit, starting with the unperforated release film, followed by a breather layer, and then we're putting that into an envelope vacuum bag.
The purpose of this release film is to provide a non-stick, impervious barrier between the pre-preg material and the breather layer which we will be adding next. Pre-pregs have perfectly measured resin to fibre ratios, and so we don't want the breather to absorb any resin from the laminate, which is why we always use unperforated release film with these pre-pregs. Ensure the film covers the whole surface of the part without any tight spots or bridging, using some tape to hold it in place. Don't worry about overlaps and creases, as these will not have an adverse effect on the part. Check again carefully for any bridging, particularly in the corners.
So now we're onto the breather layer, which again we're going to put into the mould in just the same way that we did the release film.
The breather cloth is there to maintain air paths through the bag. It should be positioned across the whole surface of the mould and then held in place with some tape.
To eliminate the chances of any of these sharp mould edges or the bolts themselves puncturing the bag, we're also going to wrap the back of the mould in some breather, and this will offer a reasonable degree of protection. Now we're going to use the vacuum bagging film from the kit to make an envelope bag, so a bag that all of this goes inside, and seal it. To seal the bag, you want to go slightly beyond the fold in the film, and then lay your sealant tape flat onto the bag. And then that fold, once the backing tape's been removed, can be doubled back on itself, and that'll provide a perfect seal. Makes life a lot easier if at this point you also apply the seal to the other side, but obviously don't seal the bag up completely.
Lift the whole mould and the extra breather layer surrounding it into the vacuum bag.
Through bag connectors, the next thing, easily forgotten. So we put one insert on the inside there, and then pinch a small amount of the bag, snip it, place that side of the insert through the bag, and then firmly tighten the two together.
And now that both the part and the through bag connector are where they should be inside the bag, we can peel off and seal the tape that we positioned earlier.
We're now ready to pull a vacuum. So all we need to do is take the Composites vacuum pump, connect our high temperature silicone hose to it, and then to the through bag connector. Switch the pump on and we'll gradually pull down the bag whilst positioning it.
Being such a complicated shape, it's perhaps a little difficult to see exactly what's happening here as we first begin to pull down the vacuum. Essentially, what I'm doing is feeding all of the surplus bag inside the mould through the aperture in the base, and then pushing this surplus of bag up into the neck of the airbox, whilst at the same time pushing more surplus bag into the neck from the other side. As the bulk of the air is removed from the bag, you'll want to periodically close the vacuum valve to provide sufficient time to reposition the bag. It's essential that by the time the bag starts to tighten up, it's being carefully positioned and jostled into place so that it's properly into all of the corners of the mould without any bridging or tight areas. You can see here where the vacuum bag that's been pushed into the neck from the inside meets the bag that has been pushed in from the outside. We need to make sure that there's no bridging around the outside of this area too.
With the bag fully pulled down, all that's left to do now is cure this part. To do that, we're going to be curing this at 80 degrees C, which is 176 Fahrenheit, for 8 hours.
Here we're using our own specialist Composites curing oven, which gives us plenty of space for loading parts like this, and also has vacuum lines already available inside the oven. It is, however, perfectly possible to cure pre-pregs in a range of different types of oven, from small domestic ovens through to large industrial ones. The key thing is that you need a vacuum line into the oven to maintain vacuum throughout the cure. For more information on pre-preg cure cycles, including ramp rates and cure times at different temperatures, please download the companion PDF guide that accompanies this tutorial.
Now that we've left the part to cure for 8 hours, all that's left to do is remove it from the oven, allow it to cool, and demould it. We're back down to room temperature now, so we can look at removing the bag.
Like most vacuum bagging processes, we generally regard the vacuum bag as disposable, but don't forget to remove the through bag connector first. Breather cloth can, if you like, be saved and used repeatedly, but like the bagging film, the release film is normally discarded. Once the consumables have been removed, we can unbolt the various sections of the mould to release the part. The easy release we used earlier ensures that the part releases incredibly easily.
So you can see what we're left with here is just some flash lines that can be cleaned up, and then the trim around the lower section to make the final part. A quick way of cleaning up the flash lines is just taking a Stanley blade and scraping it across the surface until the flash has been brought down to a minimum. To trim the part, we'll be using a Dremel Fortiflex, which in our daily production environment has proven itself to be incredibly reliable. Fitted into the Dremel is a Permagrit tungsten carbide wheel, which is absolutely perfect for cutting carbon fibre.
The Fortiflex is great because its remote motor keeps the electrical part of the tool away from the conductive carbon fibre dust, which would quickly damage the smaller handheld models. And its foot pedal operation leaves hands free to concentrate on the trim. Permagrit sanding blocks and round files are ideal for shaping and correcting the cut edge before taking it to a smooth finish with some abrasive paper. For lots more information on trimming, check out our video tutorial on cutting and shaping carbon fibre. Once all the edges have been nicely smoothed off, our brand new, top spec carbon fibre part is finished and ready to use.
I hope you've enjoyed this video series. We finally got there. We started out from an original design idea, we made a pattern, carving it out of foam, gone on to making a split mould, and finally, pre-preg carbon fibre part. I hope this gives you the confidence and inspiration to take on your own project, no matter how complex. If you do take on your own project, we'd love to hear from you. Get in touch with us on our Facebook, Twitter or forum. Of course, if you want to be the first to hear about our videos as we release them, subscribe to our YouTube channel.